Hey, what's up? This is Shaheen Chakar, and I'm here to go over variables. Hiya! Hi, this is Shaheen Chakar, and we're going to be going over inequalities with one variable today. What up? Here we go. So I'm looking at 2x is greater than negative 16. And what I want to be doing is isolating the variable. What that means is I want to get this x all by itself, that it's lonely. Okay, so I want to get it all by itself. Now, how would I get the variable by itself? Well, the key is I got to look over here and see what is next to the x. And here I see a coefficient of 2. And what does it mean when I have a coefficient or a number next to a letter? It's telling me I'm multiplying. Okay, that's what's happening in this operation. But I want to isolate the variable. So to isolate the variable, I have to do the inverse operation. I got to do the opposite thing. So what is the opposite of multiplying times 2? It is dividing times 2, dividing by 2. So here we go. I have 2x, and I'm going to divide by 2, but I can't just do it to one side. You know, you got to have things equal. So I got to do it to the opposite side as well. I got to divide by 2. This is called the division property of equality. Got to be equal to both sides. Got to share the cookies to everybody. Here we go. So I have 2 divided by 2. 2 divided by 2 gives me 1. And so here I have 1x. But I don't need to write the coefficient 1 because I just know there's how many of these? Oh, look, there's one of them. So I go with that. And then I have negative 16 divided by 2. Negative 16 divided by 2 gives me a negative 8. Now, because I didn't change the value of x from positive to negative, it just stays positive the whole time, all right, which is good. We're going to keep the sign the same so that x is still greater than negative 8. So once again, the way we did this is I divided by 2, which canceled that out, and I divided by 2 on this side, which gives me negative 8, and now I have x is greater than negative 8. Now the idea is that I got to go ahead and graph this bad boy. So to graph this, I go ahead and mark where 0 is, and then I go ahead and mark where negative 8 is. So in doing that, I can now state that x is everything greater than negative 8. Everything greater than negative 8. Now, I'm going to draw a circle around negative 8 right here on the number line because x does not equal negative 8. It's greater than negative 8. So if x is everything greater than negative 8, it goes to the right. So everything I own in a box to the right just pushes over here. So the idea is x can be any of these numbers to the right. X can be 15 because 15 is greater than negative 8. X could be negative 7 because negative 7 is greater than negative 8. It's an exciting time. You know what I'm talking about. Moving on. What if I had an eraser? That would be super useful. Be right back. And I'm back. You know what's up. So what if I was going to go ahead and have a different equation? What if I had 3x is less than or equal to 20? Now when I have a little line underneath my greater than less than sign, it means or equal to. And we'll talk about that in a second. Now, let's go ahead and let's isolate this variable. We talked about isolating variables before as doing inverse operation. So, in this case, I'm multiplying times 3. That's 3 times x, because that's the coefficient. The coefficient is 3. I want to isolate it. So, I'm going to divide now by 3. So I'm going to divide both sides by 3. Boom! Alright, so in dividing both sides by 3, I now have x by itself, because 3 divided by 3 is 1, and so I have 1x here, and you can think to yourself that there's 1 right here, but you don't have to. You can just go ahead and erase that and make a big smudge. Continuing. Next I have 20 divided by 3. Alright, I have 20 over 3. And because the value of x didn't change from a negative to a positive or a positive to a negative, it's still, the arrow still points the same direction. X is still less than or equal to 20 over 3. Now, this is called then improper fraction. So we don't want to keep an improper fraction. We want to go ahead and change it into like a mixed number. So I think, how many times does 3 go into 20? 3 goes into 26 times, okay? So I have 6, and then what's left over? 2. So I have 6 and 2/3. And I have x is less than or equal to 6 and 2/3. How would I draw that on a number line? I'm glad you asked that question. I'd go ahead and draw my number line and mark a 0. And I go ahead and I have like where 6 is, and I have where 7 is, and I can mark where 6 2/3 is. It's going to be between these bad boys. And so 2/3 is a little past halfway. In fact, well, no joke there. Okay, so now in this case, previously we did an open circle, right? But this time, and we did an open circle in the last problem because it was just greater than or equal to, or less than or equal, it was just either greater than or less than. In this case, it's equal to. So x actually can be 6 2/3. So I fill in that dot, because it can be 6 2/3. But then it's also everything, what? It's everything less than. So I go ahead and I can shade everything less than 6 2/3. For example, 0 is less than 6 2/3. That can be a value for x. Negative a billion can be less than 6 2/3. But I'm not going to show that. This just implies that it would go that far. Right on. So let's do one more example. And I can hear the cheering through the computer right now to see one more example, because I know what you like. So what's up? All right. Now continuing, if I had one more equation like 2/3 x. Let's go plus 5 is a greater than or equal to 25. How could I possibly solve that? All right, so we want to get x by itself. That's the plan. Because I want to get x by itself, let's go piece by piece, own in this bad boy. So step 1, what would I do? I would get rid of this plus 5, okay? So inverse operation, I'm going to go ahead and what is the opposite of adding 5? It's going to be subtracting 5. Or you can say adding negative 5, but that's up to you. So I'm going to subtract 5. Yeah! Hey! All right, these two cancel out because 5 minus 5 is, and then I have 25 minus 5, so I'm going to rewrite my problem because I love looking at my problems slowly getting handled. So now I have 2/3 x is greater than or equal to 20. What would I do now? I don't even know. Actually, I do. So the idea is if I'm multiplying times 2/3, I would then divide by 2/3, but that's crazy. That just looks like a mess. So the idea, hello again, the idea is that I would, to divide fractions, you have to use the multiplicative inverse. The multiplicative inverse. So that would be multiplying by this bad boy flipped. So I'm multiplying by 3/2, and I got to do it to both sides because that's the multiplication property of equality. You got that? Yeah, you do. Yeah, you're awesome. So I can cross cancel stuff, and 3 goes into 3 one time, and 2 goes into 2 one time. Oh, what do you know? 1 times 1, oh, it's 1. So I have x over here. All right? Now I have 20 times 3/2. I'm going to put 20 over 1, so I can go ahead and do this like fractions. You know what I'm talking about. So then, can I cross-cancel anything? Yes! So what can I cross-cancel? 20 and 2? What? So I go ahead and cancel. How many 2's are in 2? 1 of them. How many 2's are in 20? 10 of them. What is 10 times 3? It's 30. That's right. What's 1 times 1? Oh, it's 1. So I get 30 over 1, which reduces just to 30. Now, I want to fill this in. Yeah. Let me ask you this question. Did the sign on the x change to like a negative or positive? No, it did not, so it still stays, the sign will still stay the same. In the next video, I'll explain that a little more. So, we have x is greater than or equal to 30. That being the case, I go ahead and graph a 0 and then mark a 30. And if you want to put 30 dashes in between, that's up to you. You got the free time? Nice. All right, so the idea here is x is everything greater than or equal to 30. So does x equal 30? Let me think about it. Yes, it does. So I go ahead and I mark 30. Boom! And then I'm going to go ahead and graph everything that is what? Less than or greater than? Greater than 30. So everything on this side. So everything over there is graphed because it's greater than 30. Can x be 31? Yes. Can x be 30? Yes. Can x be 29? No. Can x be a billion? Yes. So that's what that marks. Okay? That everything on that side of 30 is going to be a possible value of x. So I hope this was helpful, and if it wasn't, I at least hope you enjoyed watching my caffeine rush. So have a great day, and I hope you are a little more comfortable with graphing inequalities in one variable. Peace.